Good morning friends. Today we learn about the projection of points. Projection of points means in which we draw the front view and top view of the point for the given condition. Okay, so after projection of point we learn about the projection of line, projection of plane and projection of solid. So this topic is very important for you. Okay, so before starting projection of point, let's revise some important points from the orthographic projection that we already learned. Okay, in orthographic projection we learn about the three principal plane. Okay, planes are horizontal plane, vertical plane and profile plane. Okay, here I draw two plane. This one is vertical plane and horizontal plane. Okay, I'm not drawing profile plane here. This one is my vertical plane and this one is my horizontal plane. Okay, if I take one object at here, if I take one cube at here, okay, and if I see from this side, okay, then its projection will seen on vertical plane. Okay, and I get its front view. And if I see the object from the top, I seen its top view on horizontal plane. Okay, so one thing that we conclude here, that I get the front view of the object on vertical plane and top view of the object on horizontal plane. Okay, now if I talk about the notation, then for example this side is A, B, C, D. Okay, then for front view I use the small alphabet with dash. So here I get A dash, B dash, C dash and D dash. Okay, and for top view I use simple small alphabet. Okay, here I give the name E and F, E, F. Okay, so my top view is A, B, E and F. Okay, so for front view I use the simple alphabet with dash. For example A dash, B dash, and for top view I use simple small alphabet A, B. Okay, and if I talk about the side view represented by A double dash, B double dash. Okay, now this is the pictorial view. Okay, this is the pictorial view of the object. Okay, pictorial view for the front view and top view. Okay, if I want to draw orthographic presentation or orthographic view, if I want to draw the orthographic presentation for this object, then I simply require to rotate this horizontal plane 90 degree in clockwise direction. 90 degree in clockwise direction. Okay, so I get this plane at simple here. Okay, so I get my horizontal plane exactly below the vertical plane. Okay, I represent it at here. Okay, if this one is my vertical plane, then I get the horizontal plane exactly below. Okay, this is my horizontal plane. Okay, so in this way I represent its orthographic presentation. Okay, this one is pictorial presentation and this one is orthographic presentation. Okay, let's draw its front view and top view in orthographic presentation. Okay, so here I draw its front view that we get in pictorial presentation and give the name A dash, B dash, C dash and D dash. Okay, and here in horizontal plane I draw its top view okay, and give the name A, B, E and F. Okay, so this one is top view and this one is front view. Okay, so here important thing is this one. Okay, we get the front view on vertical plane, top view on horizontal plane and side view on profile plane. Okay, we use the notation A dash B dash for the front view, small ab for top view and A double dash B double dash for side view. Okay, now if I seen from this side, then my vertical plane is look like this. Okay, and horizontal plane is look like this. Okay, so this one is my vertical plane and this one is my horizontal plane. Okay, now we know about the quadrant. Okay, here this one is first quadrant, this one is second quadrant, this one is third and this one is fourth quadrant. Okay, now let's come to the projection of point if my point is in first quadrant. Okay, if my point is first quadrant, I take here condition that point I draw the projection of point R. Okay, and condition for the projection R is the point R is in first quadrant, so it's above the HP by X mm. Okay, and it is 50 it is Y mm in front of VP. Okay, it means here the point is X mm above the HP. Okay, so this one is my horizontal plane and the point is 10 X mm above the HP. Okay, this one is my horizontal plane and point is X mm above the HP. So I simply measure X mm distance at here, X mm distance, and draw on horizontal line. Okay, and the second condition is, so this one is locus of my point. Okay, locus. Okay, it is very useful in projection of line. Okay, locus means it is a set of a point which have same distance from the reference line or the horizontal. Okay, here I take the horizontal plane as a reference, so on this line if I take any point, it's have a same distance from horizontal plane. Okay, so it's called the locus. Okay, now second condition is it's a Y mm in front of VP. This is my vertical plane and my point is in front of VP. Okay, so in front of VP, so I take Y mm distance from here, Y mm distance, and draw one vertical line. Okay, so intersection of these two lines give me my position of point R. Okay, and for drawing the front view, I seen from this side, so I get here my front view, I give the name R dash. Okay, and for top view I seen from this side, then my top view I seen at here, I give this name small r. Okay, so here the important thing is about the condition. Okay, here we have two plane, one is horizontal plane and second one is vertical plane. Okay, so if I talk about the condition, then for the position of the point is given with respect to these two plane, horizontal plane and vertical plane. Okay, with respect to horizontal plane we have two conditions, that my point is above the HP or below the HP. For example, here above the HP and below the HP. Here above the HP and below the, this is my horizontal plane, so either the point is above the HP or below the HP. Okay, and if I talk about the vertical plane, okay, for vertical plane I have two conditions, either the point is in front of vertical plane, or behind the vertical plane. Okay, for example, this is in front of vertical plane or in front of vertical. This is my vertical plane, so in front of vertical plane or either behind the vertical plane. Okay, as I told you that projection of points means we simple wrote its front view and top view for the given condition. The condition is this four condition. Okay, we use this four condition. Okay, this condition we learned 6 cases. Okay, so after that you clear about the all conditions. Okay, so start one by one. Okay, our first condition is if my point A is in first quadrant. Okay, first quadrant means the point is above the HP and in front of VP. Okay, here for first quadrant, if I talk about the condition is if my point is in first quadrant, that the condition is it is above the HP and in front of VP. Okay, and for second quadrant the condition is it's above the HP and behind the VP. For third quadrant it is below the HP and behind the VP, and fourth quadrant it is below the HP and in front of VP. Okay, so let's see one by one all the condition. Let's start with the point A. Okay, first condition is my point A is in first quadrant, so means it is above the HP and in front of VP. Okay, here given the condition that the point is 10 mm above the HP. Okay, 10 mm above the HP and 15 mm in front of VP. Okay, so first I draw the pictorial presentation. Okay, for that I simply draw vertical plane here and horizontal plane. This one is horizontal plane and this one is vertical plane. Okay, here the given condition is the point is 10 mm above the HP. So here from here I measure the 10 mm distance and draw one horizontal line. Okay, this distance is 10 mm. Okay, and second condition is the point is 15 mm in front of VP. This one is my vertical plane, point is 15 mm in front of, so I measure 15 mm at here, 15 mm, this distance is 15 mm. Okay, and draw one vertical line at here. So intersection of these two lines give me the position of my point A. Okay, now here I draw the front view and top view for this point. Okay, so for drawing the front view I seen from this side. Okay, for getting its front view I seen from this side and I get its projection on vertical plane. Okay, and I give the name A dash. Okay, for drawing the top view I seen from top, so I get its projection on horizontal plane at here and I give the name small a. Okay, so this one is a pictorial presentation. To draw the horizontal presentation, I simply rotate the horizontal plane about 90 degree in clockwise direction. Okay, so I get like this. This one is my vertical plane. Okay, and this one is my horizontal plane, and this one is reference line XY. Okay, so this one is my horizontal plane, and above the reference line I have my vertical plane. Okay, so getting this point A on horizontal plane, I rotate. If I rotate the horizontal plane at below, then this one is my horizontal plane. Okay, and for getting this point I simply take this one as a center and 15 mm as a radius. I draw one arc at here, this arc. Okay, so I get my point at here, so I get a point here. So for simply draw the orthographic presentation, I first draw the front view, and for front view I measure 10 mm. Here the condition is 10 mm above the HP, so I simply from here reference line measure the 10 mm and mark the point at here and give the name A dash. Okay, so A dash is my front view for the point A. Okay, and for top view I simply, as I seen, the top view is below the reference line and distance is 15 mm. Okay, so distance is 15 mm in front of you, so from here reference line I measure 15 mm distance and mark the point small a. Okay, this one is my top view for the point A. Okay, so conclusion of this case is if the condition is given for the HP, if the point is above HP, then I draw the point above the reference line. Okay, and for the vertical plane, if the condition is given point is in front of vertical plane, then I draw the point below the reference line. Okay, by taking the given distance. Okay, here the given distance HP is about 10 mm, so from reference line I measure 10 mm. This distance is 10 mm. Okay, and for VP, condition is 15 mm in front of VP, so from reference line I measure 15 mm distance and I draw my top view point A. Okay, so the conclusion of this case is this one. Okay, now let's say the second case. In second case, the point B is in second quadrant, and the condition given is point is 10 mm above DHP and 15 mm behind VP. Okay, so first I draw a vertical plane and horizontal plane. Okay, here I draw the pictorial presentation first. Okay, so here the condition is point is 10 mm above DHP. Okay, so here first I take the 10 mm distance, point is 10 mm above HP4. So here horizontal, from horizontal plane, and this one is vertical plane. Okay, so from horizontal plane I measure the 10 mm distance and draw one horizontal line. Okay, this distance is 10 mm. Okay, and second condition is point is 15 mm behind VP. Okay, so from here I measure the 15 mm distance and draw one vertical line. So intersection of this point give me my position of point B. Okay, now for drawing the front view, if I see from this side, I get the front view on vertical plane at here. So I give the name B dash. Okay, and top view I get on the horizontal plane at here, and I give the name small b. Okay, now for getting the orthographic presentation, I simply rotate this horizontal plane in clockwise direction at 90 degree. Okay, so I get horizontal plane at here. Okay, so here we see that the horizontal plane and vertical plane are overlap to each other. Okay, and to getting this position, this point B, I simply take this one as a center. This is a center, I give the name O as a center, and 15 mm as a radius. I draw the R which intersect the horizontal plane at here. So I get my point B at here. So I get my point B at here. Okay, now if I represent in orthographic presentation, I simply draw vertical plane. This one is reference line XY, and above the XY line is vertical plane, and here is the horizontal plane. Okay, so when my point is in second quadrant, as I seen, the horizontal plane and vertical plane are overlap each other. Okay, here condition given that the point is 10 mm above HP. So from here I just simple measure 10 mm distance. This distance is 10 mm and mark the point B dash. So this one is front view. Again, for top view I measure the distance 15 mm. So from here I measure the distance 15 mm. This distance is 15 mm and mark the point B. So this one is my top view and this one is my front view. Okay, so conclusion of this case is, if the point is given above DHP, okay, above DHP, then we draw the point above the reference line. And for VP, if the point is behind VP, okay, then we draw the point above the reference line. Okay, so this is the conclusion for this case. Okay, here the condition given is point is 10 mm above HP, so we get the point above the reference line, and second condition, point is 15 mm behind the VP, so we get the point at above the reference line. Okay, so this is our conclusion for the second case. Okay, let's see the third case. Okay, let's see the third case. In third case, the point is in third quadrant. Third quadrant means the point is below HP and behind VP. Okay, so here condition is point is 10 mm below HP and 15 mm behind VP. So first I draw horizontal plane and vertical plane. Okay, now here the condition is point is 10 mm below HP. So from HP I measure the 10 mm distance at here and draw one horizontal line at here. Okay, this distance is 10 mm. Okay, and from vertical plane, point is 15 mm behind VP. So from here I measure the 15 mm distance and draw one vertical line. So intersection of these two lines give me the position of point C. Okay, and I get the front view of the point C at here on vertical plane, so I give the name C dash, and top view of the point C at here, so I give the name small c. Okay, now I just rotate the horizontal plane 90 degree in clockwise direction. Okay, so I get point C at here. So for drawing this, I just take this as a center and 15 mm as a radius. I draw one arc at here. which intersected here. Okay, so here I get my point C. Okay, so this one is top view and this one is front view. Okay, so if I take reference line, one reference line at here, okay, then for front view condition is 10 mm below HP. So from here I take 10 mm below and mark the point C dash. Okay, this distance is 10 mm. Okay, and for drawing the 15 mm behind VP, here I see that it's above the reference line. So from the reference line I take the distance 15 mm above and mark the point C. Okay, this distance is 15 mm. Okay, so here conclusion of this case is if the point is below HP, then we draw the point below the reference line, and if the point is behind vertical plane, then we draw the point above the reference line. Okay, so this is the conclusion of this case. Okay, let's see the fourth case. In this, the point D is in fourth quadrant, and for fourth quadrant point is below HP and in front of VP. Here condition given is point is 10 mm below HP and 15 mm in front of VP. Okay, so first I draw horizontal plane and vertical plane. Okay, now here the condition is 10 mm below, so from here I measure the 10 mm line and draw one horizontal line at here. Okay, this distance is 10 mm, and for condition 15 mm in front of VP, I measure 15 mm at here and draw one vertical line. Okay, so intersection of these two lines give me the position of point D. Okay, I get the front view at here, point D dash, and top view of the point D at here, small d. Okay, now draw the orthographic presentation. I rotate this horizontal plane 90 degree in clockwise direction. Okay, so I get the horizontal plane at here. Okay, so for getting point D on horizontal plane, I take this one as a center and 15 mm as a radius. I draw one arc which intersected here. Okay, so here I get the top view point D for the point D. Okay, so if I draw it orthographics presentation, I draw one reference line at here. Okay, now the condition given is the point is 10 mm below HP, so we measure the 10 mm from the reference line at here and mark the point D dash. So this one is front view. Okay, and for second condition 15 mm in front of. Okay, as we see that the point is below the reference line, so from here I measure the 15 mm distance and draw its top view small d. Okay, so conclusion of this case is, okay, if the point is below the horizontal plane, then we draw the point below the reference line, and if the point is in front of vertical plane, then we draw the point below the reference line. Okay, so this one is conclusion for this case. Here in fifth case, the condition is point E is 10 mm above the HP and on VP, so point is on vertical plane. Okay, so first I draw to reference line at here. First I draw the horizontal plane at here and vertical plane at here. Okay, now the point is 10 mm above HP, so from here I measure the distance 10 mm and draw one horizontal line. Okay, this distance is 10 mm. Now the second condition is point is on VP, so point on this vertical plane, so intersection of this is at here, so my point E is at here. Okay, so I get the front view. For front view on VP, so I get to my front view exactly at here, so I give the name E dash. Okay, and for top view I get the point at here and I give the name E. Okay, so here the conclusion of this case is, if the point is on VP, then we draw the point on reference line. On reference line. Okay, so this is the conclusion of this case. Okay, let's see the sixth case. Point F is on HP and 15 mm in front of VP. Okay, so first I draw vertical plane and horizontal plane at here. Here the condition is point is on horizontal plane, so the point on this plane, and second condition is point is 15 mm in front of VP. This one is vertical plane, so I measure the 15 mm from here, so I get my point F at here. Okay, so, and the front view of the point I get on vertical plane at here, so I give the name F dash, and top view of the point at here, so I give the name small f. Okay, now to getting the orthographic presentation, I rotate this horizontal plane 90 degree in clockwise direction. Okay, so for that I just simple take this one as a center and 15 mm, this distance is 15 mm, 15 mm as a radius. I draw one arc at here, so I get my top view at here. Okay, so for representing this point I simply want to draw reference line. Okay, now here the point is on HP, so my point F dash at here, so I give the name F dash at here. Okay, now draw the point F. I simple draw one vertical line at here and measure the distance 15 mm. Okay, 15 mm, so this distance is 15 mm. I get my top view F at here. So the conclusion of this case is, if the point is on HP, then we draw the point on reference line. Okay, and if the point is in front of VP, then we draw the point below the reference line. Okay, so this one is conclusion of this case. Now we see the conclusion of all these 6 cases. Okay, this one is very important for you to solving the problems. Okay, so let's conclude all 6 cases. Here, after the conclusion of 6 cases, we learned that for horizontal plane we have 2 conditions: either the point is above HP or below HP. Okay, and for VP we have 2 conditions: either the point is in front of VP or behind VP. Okay, if the point is above HP, then we simple draw the point above the reference line. Okay, if the point is given 10 mm above, then we simple draw the point 10 mm above the reference line. Okay, and for point below the horizontal plane, we simple draw the point below the reference line. Okay, and for vertical plane, if the point is in front of VP, then we draw the point below the reference line. And for point behind the vertical plane, we simple draw the point above the reference line for given distance. Okay, if the point is 15 mm in front of VP, then we simple measure the 15 mm below from the reference line. Okay, and if the point is 15 mm behind VP, then we simple measure the distance 15 mm above the reference line. The point is on HP or VP. Okay, either HP or VP, we simple draw the point on reference line. On reference line. Okay, so this is our conclusion of all 6 cases. Okay, so this one is very important for you to solving the problem, so please note down this one. Okay, if you remember all 6 cases, then it may be confusing, so you no need to remember all the thing. You just remember one condition. Okay, and that is, if the point is in front of VP, then simple we take the distance below the reference line. Okay, horizontal plane we no need to remember anything, because if the point is given above, then simple take the distance above the reference line. If the point is below the HP, then the simple take the distance below the reference line. Okay, so we just remember the condition for the vertical plane, and only one condition: if the point is in front of VP, then simple take the distance below the reference line. Okay, so if the point is behind, then it's opposite, take the point above the reference line. Okay, and for on HP and on VP, just take the point on reference line. Okay, so only we need to remember is this condition: if the point is in front of VP, then we take the distance below the reference line. Okay, so note down this condition. Okay, after that we solve some problem. Okay, let's solve this problem. Okay, in this problem there are 9 points are given. Okay, and we represent this 9 point. Okay, means we draw the projection of this 9 points. Okay, in exam 3 to 4 point may be asked. Okay, and each point contain 1 marks. Okay, so it's about 3 to 4 marks. Write down only one condition at here: if the point is in front of vertical plane, then I draw the point below the reference line. Okay, so from the conclusion of the 6 cases, let's solve this problem. Okay, first start with the point A. Okay, here for solving the problem, first I draw this reference line XY. Okay, let's start with the point A. Here the condition for the point A is 40 mm above HP. Okay, 40 mm above HP. Okay, and we know that for above HP, we simple draw the point above the reference line. Okay, so from here reference line, I just simple measure the 40 mm distance. okay, 40 mm distance, and mark the point A dash. This one is front view. Okay, so I mark the point A dash. Okay, now for another condition is point is 20 mm in front of VP. Okay, and in front of we take the point below the reference line. So from here I just simply measure the distance 20 mm, okay, below the reference line, and mark the point A. So here I draw the projection for the first point. Let's come to the second point here. Okay, here for point P, condition given is 35 mm above HP and 25 mm behind VP. Okay, for 35 mm above HP, for above HP, simple draw the point above the reference line. So from here I just simple measure 35 mm distance and mark the point B dash. Okay, and for another condition 25 mm behind VP. Behind means opposite of this. So if the point is behind VP, then we simple draw the point above the reference line. So here the 25 mm behind. So from here I just simply measure the distance 25 and mark the point B at here. Okay, this distance is 25 and this distance is 35. Okay, let's come to the third point. For point C, condition is 25 mm below HP. Okay, for below HP I just simple take the distance below the reference line. So from here I just simple measure the 25 mm distance and mark the point C dash. Okay, and second condition is point is 30 mm behind VP. Behind VP means take the distance above the reference line. So here I measure the 30 mm distance and mark the point C. This distance is 30 mm. Okay, and this distance is 25 mm. Okay, let's come to the fourth point, which is point D. Point D is 45 mm below HP. So from here I measure the 45 mm below HP, 45 mm distance, and I mark the point D dash. And second condition is 25 mm in front of. In front of means below the reference line, and distance is 25. So from here I measure the distance 25 and mark the point at here and D. Okay, so this distance is 25 and this distance is 45. Okay, let's come to the point E. For point E, condition is 35 mm above HP. So from here I just simple measure 35 mm and mark the point E dash. Okay, and second condition is point is in VP. Okay, for in VP, as we know that the point is on HP or on VP, the symbol draw on the reference line. Okay, so I mark the point at here and give the name E. Okay, so this is top view and this is front view. For point F, condition is 35 mm below HP. So from reference line I take the distance 35 mm below. Okay, so from here I measure the distance 35 mm and mark the point at here F dash. And second condition is point is in VP. Okay, so if the point is in VP, then I get the point on reference line. So I mark the point F at here. Okay, so this one is top view. Let's come to the point G. For point G, the condition is point is in HP. So for in HP, so I get the point at here. I give the name G dash. And second condition is 15 mm in front of. For in front of, we simple draw the point below the reference line. So measure the 15 mm distance at here, and I mark the point small g at here. Okay, this distance is 15 mm. Okay, let's come to the point H. Okay, for H, condition is point is in HP. So in HP I mark the point on reference line and give the name H dash. And second condition is 25 mm behind VP. So opposite of this, behind means take the point above the reference line, and distance is 25. So measure 25 mm distance at here and mark the point H at here. Okay, so this distance is 25 mm. And last point I is in HP and in VP. Okay, so in HP, so I mark the point on reference line for in HP and give the name I dash. And for VP, condition is in VP, so point is exactly at the same position, so I give the name I. So in this way we solve the problem of projection of point. Okay, here the student confusing about the notation. Okay, where they give the A dash and where they write simple small a. Okay, so here I write down one thing that, okay, we used small alphabet for the top view. Okay, and for and we use a dash for front view. Okay, we use the small alphabet with dash for the front view. Okay, so when I draw the front view of the point, I use the notation a dash, and for drawing the top view of the point, I use the notation small a. Okay, and if you confusing about the HP and VP, okay, then we know that we draw the top view on horizontal plane and we draw the front view on vertical plane. Okay, here if you are confusing about the notation, okay, let's solve this problem at here. Okay, for example, here if I take one point at here, okay, at distance of x mm above the HP and y mm in front of VP. Okay, so I get the point at here, I give the name R. Okay, so I get its front view at here, R dash, and top view at here, small r. I told you earlier that we use small alphabet for representing top view and small alphabet with dash we use for the front view. Okay, so here I use R dash for the front view and small r for the top view. We have the condition with respect to HP and VP. Okay, so here the condition is the point is x mm above the HP. Okay, so if you see carefully that here we use this distance x mm at here. Okay, we use this distance above x mm to the HP for drawing the front view. Okay, so if the condition is given with respect to HP, then we noted this point with dash. Okay, and for VP here the condition is point is y mm in front of VP and we use this distance to draw its top view. Okay, so the condition given with respect to VP, we mark it with the small alphabet. Okay, I hope your confusion is clear at here. If you draw the point with respect to HP, then noted it with small alphabet with dash, and if you draw the point with respect to VP, then simple it represent by small alphabet. Okay, let's see in our solving problem here. Here for first point, if I mark the point 40 mm above HP, means the condition with respect to HP, then I simply it represent by dash, and if I draw the point with respect to VP 20 mm in front of, then I it represent by small alphabet. Okay, seen in second problem, here the condition for the HP is 35 mm above HP, so for respect to HP I draw B dash at here and I mark it with the dash. Okay, and for VP condition is 25 mm behind VP, so from here 25 mm and I mark the point with small alphabet. I noted the point with small alphabet. Okay, if I see in this case condition is 25 mm below HP, so with respect to HP I mark the point at here and represent by C dash, and for here condition is with respect to VP is behind VP, so I measure the distance 30 mm at here and mark the point with small alphabet. Okay, so here I conclude this lecture. Thank you.